welcome. We got another project for you today, and we're going to do some analog to digital transformations involving lights. We're going to have some light affect something, light from our environment, affect our circuit. It's going to input as analog, and then we're going to change it to digital, and then we're going to have it output digitally through more light. So light to light. So let's go ahead and get started and switch views. I think that's the one I want. There we go. The part we're going to use today is right here. There's a little solar cell. When light strikes it, it changes the amount of resistance. So it's like a variable. Here's a resistor right over here. These guys, they restrict the flow of current going through them, but they're fixed. Whatever value when they're manufactured, this one's a 5,000, whatever value that is, it's always a 5,000. This one over here is 330. It's always going to stay that way. But this device, depending on the amount of light striking it, its resistance is going to change. And that's not atypical. A lot of sensors, they operate on the idea that its physical properties will change depending on, like, say, the temperature. Temperature change will cause the resistance to change, and so you use that resistance change to figure out how the temperature is changing. In this case, we're using light. So let's go ahead and hook this up and gather some data from it. Take a look at it on our serial monitor, and then we'll do something with it, something interesting with it. Alright. Okay, so I've already got this pressed in. There's no polarity we have to worry about. We don't care which direction, whether it's in this way or if you flip it around. It doesn't matter. So we're just going to put it in here. And grab a couple wires. In fact, just plan ahead. Let's plan ahead and go ahead and use these rails at the bottom here. Let's put the ground, go for Arduino, and let's hook a ground up to this rail. We'll use, there's one right over here. Let's move that a little closer so you can see. My camera's kind of zoomed in a little bit. So I'm in the ground. And we're going to plug it in here. So now this whole rail here is, they're all connected. They're all ground. And let's do the same thing for, the 5.5 volts, which is right there. I'll plug that in. And then we'll run that over to the plus side. So now this whole side is 5 volts. Now I've got access to it, easier access to it from my breadboard than having to string wires all the way over to here. I'm going to run out anyway. I only have one 5.5 outlet. I do have 3 grounds on here, 2 here and 1 here, but some Arduinos have less. So that'll be nice. I'll get it started there. So our photocell here is going to need one side going to ground. So now I can just go like that. Easy enough. And the other side, you might think that perhaps I could just, I'm going to set up a hypothetical for some students. You might think that I could just perhaps send 5 volts, here's a pretend circuit, through my solar cell, and then over here, and then we're going to capture, we're going to go to the, you don't have to build this part, I'm just showing you what we actually can't do. And I can run it into my A5 or one of my analog, so I'm going to read, my output's going to be an analog output, so I got to use one of these analog pins. I say, okay, so I put my finger over here and we change the amount of current but this thing is not going to be able to measure current. It's only going to be able to measure voltage changes. So unfortunately, with a simple circuit like this, my drop in voltage is always going to be the same. So I can't measure anything with it just like this, with just a single loop going from here into my device and then back into my Arduino. So what I have to do, I have to do a little trick. So I wanted to explain that because it's a little bit unusual what I'm doing. So I'm going to pull these back out, start from scratch, like that. And what I have to add is one of these 5K resistors, a 5,000, roughly 5,000 ohm resistor. And we're going to put it into that row here, the same one that, we'll bend that back a little bit. I want these to be in the same row. And what we're going to do, ultimately, is I'm going to, this yellow wire, yours doesn't have to be yellow of course, it's this wire that I'm going to input into my analog pin on my Arduino. So I'll have a fixed resistor and a variable resistor, and I'm going to have a difference in voltage drop between these. And so that difference is what I'm going to be measuring. It's a little trick you use. And I'm going to need a little longer wire, so I'm going to grab a different one. So I've got a real long one. We're going to send it over to, let's do A5. I like using A5 instead of A0 because sometimes the letter O looks like a 0. So I'm going to use A5. So I still need to send one side to ground and one side to 5 volts. So let's go ahead and do that. Let's send this side to 5 volts. I can do that quite easily now that I've made these two rails 5 volt and a ground. And the other side we'll just send to ground. Okay. Pausing so you can see that. Now what I've got set up right here, I actually could have just made these two go right into the Arduino, but we're going to add a little bit to this. So I'm kind of prepping for the next half of this. Okay, so let's see what we've got. Let's just read what's the effect of my voltage change that's occurring when I change the amount of light going on to this device. We're going to have this Arduino read it, take a look at it, and then we'll do something useful with that information. So let's go ahead and switch to do a little programming here. Let's get rid of these comments. And let's start off, we're going to need to turn on our serial monitor. And there's the baud rate. We're going to have it send the information to our monitor so we can actually see it by printing it to the monitor. And we're also going to need a pin mode. We're sending information into, we're going to send information from our solar cell through this wire into our Arduino, so we have to do a pin mode A5, and it's going to be an input. Now technically all the pins are defaulted as inputs, but for just good practice we're going to put that in there. And then we're just going to want to read the value, so we're going to do analog, it's an analog signal, so analog read, and we're reading A5, and we need to store that in a variable, so we got to call it something. Let's call it photocell. Now if I leave it like this, it won't know what photocell means, so I got to go back to the top. And I'm going to declare a global variable photocell like that. Now it knows that photocell is an integer. I could locally, if I wanted to, I could declare it as a variable here, but And we're going to declare it up here above the void setup. There's advantages and disadvantages of where you declare a variable. I'm going to just put it up there so it's kind of distinct from the other parts of our program. And so we're reading the value, and then we got to be able to see it. We're reading it, and we're going to store it as photocell. But now we want to take a look at it. So serial print, go jump down to the next line, and what do you want to print? We want to print photocell. And we're going to add delay, because if we don't, the serial monitor will be spitting out numbers so fast that it'll be really hard to read them. So let's go ahead and do that. Everything looks pretty good. We set the monitor, we set the baud rate, we told it that what it's going to do is going to be inputting information. We're going to read it, store it, print it, wait. Alright, I'm going to plug in my cable here to my Arduino. The other half's already plugged into the computer. So we'll do that. My lights are flashing. It's all nice and happy. So let's go back and upload this. Let's check check tools again. Some of the times they don't automatically find the right boards. We are Arduino Uno, and it's got COM33. So that looks pretty good. Yours might, if you have a port problem, it's because it didn't select a COM, so you got to select one for it. But ours automatically selected it. And let's go ahead and upload. Asking me to save. I'm just going to hit save. You might want to give it a name. We're going to wait just for a moment. The button over here, it just does some compiling. It doesn't actually upload. So it's like a lesser version of this button. If you click on this, it'll just look over your program and look for errors. It'll translate it into language that the computer understands. And what it doesn't understand, it'll give you an error message. This one does both. So we're done with that. Let's go ahead and open up our serial monitor and see if we get anything. We're getting 500s. Let's go ahead and take my hand. I'm going to slowly move it over my photocell and see if the numbers change any. Alright. Okay. So notice they went from 185 or so up to 573. That's pretty cool. So this is the analog information we're getting from the outside world. And let's take a look at it another way. Let's go back up to tools. Since we're just looking at a number, oftentimes it's nice to look at it like this. So I'm going to bring my finger over it, and I get this drop. Then I move my finger away, and it goes back up. It's kind of jittery because we got that delay in there. We could probably actually get rid of that delay if we're using the plotter, as opposed to, we'll do a little comparison here. Let's get rid of the delay. We're not going to want it in the end anyway. So this is pretty cool. Always amazes me how little amount of code is required to gather this information. So it's done uploading. Now if we looked at it on here, it's going to go flying down. It's going to be a little harder to tell what's going on. However, on the plotter, I move my hand over it and up. Not so bad. Alright, so our extreme values are around, I don't know, about 180, almost 150. Almost 150 up to about 600. It varies. Nice analog signal there. Looks great. So now we're going to take this information, and I had to think about something interesting to do with it. So I thought we would grab one of these LEDs and use this input to output some digital information onto this LED. And we've already done a few things with these, so what else can we do? I thought it might be interesting to take this information that's coming in and use it to control the blink rate of our LED, which will be outputted as an on-off. So we're going to go back to a digital output. So from this up and down, lots of different variables, we're going to output it to turn this thing on and off. Okay, so let's go ahead and do that. Let's start off by wiring this into our circuit. It'll be separate from everything we've done. I have a little resistor over here ready to go. It is a 330. You can use 220s, 330s. You should have those available. I'm going to build a little circuit. Got my long wire. I'm going to put, just put it over here. It fits in that corner nicely. And then I've got to hook in my resistor. I'm going to add it on this side, and let's see if I can get it in that right over there. So you can get the view. So this wire and the resistor wire are both in the same row right there, and then this one terminates, that one terminates. So this side is connected to the long end of my LED, so it's this side I got to send to a pin on my Arduino, and we're going to output information through that positive side. So let's go ahead and do that. Right, let's pick 2 this time. So I just put that in pin 2 and run this all the way over to this side of the resistor, like that. And this other side right here needs to go to ground. So I'll put one in here, and then we can just sneak it right over like that. So I just added this one over to ground. So move that out of the way. I got my nice little circuit on this wire into resistor to the LED, and then this wire. Hope you can see that all right. Okay, so we're going to input the analog values here, and we're going to input them into the on and offs that are going to cause the light to go on, but we're going to use it as a delay value. So we're going to output, we're going to have it go on and off like normal, but we're going to use the input here as the delay time for our LED. So let's go ahead and do that. Let's go and douse this. Bump that there. Okay, so let's go back up to here and do another pin mode. Changes colors for us, that's good. It recognizes it. We use pin 2, and that is going to be an output. We're sending information out of that pin to our LED. And down here, let's give it a little space. Let's do digital, back into familiar territory. We're going to, on pin 2, we're going to make it high. So we got a nice digital value there, high or low. But we're going to sneak in this analog value in the delay time, so it'll cause our LED to flicker based upon how long our delay is. So we're going to use the photocell as our input for our delay time. Photocell value. We noticed it was between 150 and 600. That's what our value changed from. So we're going to put that into here. 1,000 is going to be 1 second. So it'll be, our flashing is going to be in the less than a second. Now that might be too quick. We'll try a trick to try to stretch things out, but let's go ahead and just start with inputting it directly and see if we need to do anything else. Photocell, and that looks pretty good. So the input from our photocell, we're going to put directly into the delay so that we're going to have one affect the other. I think that's all we need. Let's give this a try. Upload this. And we should immediately start seeing it blink. Okay, hopefully you can see that all right. It looks pretty good. If your light is dim, you probably didn't do the pin mode. That's nice and bright. And let's go ahead and try this out. Bring my finger over, move this to the center a little bit. Bring my finger over and see how much it affects. Okay, so it got faster. Matter of fact, let's bring up the just bring this up at the same time. Our analog signal here. And bring my finger up towards it again. So we're down here at about 250. So we got a faster delay time. So it's going on and off faster. Then I'll move my finger away, and it jumps up to 600. That slows down our delay time. So it takes longer. Now we can do one more trick with this, because why not, right? Let's get rid of that. Up here, we can actually manipulate this further. Let's do photo cell equals, there's a map function we're going to use, and we're going to be manipulating, if I can speak today, the photocell values. We're going to stretch them out. Normally they went between let's not risk it. Let's say they went 100 up to 700. I know that's a lot more than they actually went, but it's not going to hurt us if these values that I think this photocell, its maximum minimum value were. However, if the photocell values exceed these, when I use this map function, we can have some little glitches occur. So I'm going to be generous and say that the photocell values ranged from 100 to 700. And we're going to stretch those out and remap them. This would be an excellent math problem in your math class using a graph. We won't do that, of course. There's a bit of math hiding behind this that's well within your range to solve. We're going to stretch this out to say 10. So 100 values, or close to 100 values, are going to now be 10. So it'll flash really fast on those, and let's slow it down to say like 2,000 on the upper end. Okay, so it's going to read the value, read what we're getting from our photocell. We store it here. We're going to look at it. It's going to take that value, which is somewhere, it's expecting to be somewhere here, and it's going to, let's say if it was 100, it'll make that 100 become 10. If it was 700, it'll make it 2,000. And it'll scale it. It's a scaling problem. It'll scale it to this new scale. And then it'll restore it as photocell, and then it'll put in it as our delay time. So let's give that a try. Now you won't see any difference when we look at the photocell, because it doesn't change it until after. I'm going to go ahead and open up the analog, because our curriculum stresses that you know the difference between analog and digital. So let's take a look at, now they're really slow in reading because we have a delay. Before we didn't have a delay, and it's really slow right here. That's a good sign. Where maybe it's really at 600. Maybe I should have lowered this to 600, which is probably why it's not quite 2 seconds. We could adjust it, but let's just give this a try. Bring my finger over here, and we just drop down, and we didn't actually go below 200 either. It's more like 650 to 200. which is why it's not quite as fast as I'd like it to be. So we can make a little adjustment. We're pretty feeling good that it was about 200, and this is about 650. I could even go really crazy and go like 5,000 if I wanted, but I don't like to wait too much for my light to go on and off. But while we're changing things, let's might as well add a little more, another variable there. Waiting for it. Piling my sketch, gives me a moment to squeeze the pig here, and we're done. Alright, I'll take a look at it. We got it really slow. 5,000, remember, is 5 seconds. That's painful. So let's see if we can speed this thing up. There we go. Now we're flickering pretty good. Nice. Okay, so that was a good project. We took analog data from our environment and collected it, and then used that and had it be our delay rate for a digital output, the highs and lows for our LED. Okay, let's call that good, and I'll see you in the next project.